Hi there. So I got a request to do a couple of videos. One is going to be on reducing radicals or doing operations with radicals. This work comes from page 167. We're going to take a look at question 4D. So it's asking us to write as a mixed radical in simplest form. So that means the expression underneath the radical is going to need to be reduced. To reduce it, pardon me, I'm going to try to find a perfect square that divides into 60. So numbers like 1, 4, 9, 16. And so I'm going to choose 4 times 15 because 60 is 4 times 15. Then I'm going to distribute the radical over top of the 4 and over top of the 15. Now 15 doesn't reduce any further because it's not divisible by like 1, 4, 9, or 16. Those are perfect squares that we could use, but none of them are going to fit into 15. Now the square root of 4 is 2, so I'll have negative 1/2 times 2 times root 15. And these 2's are going to cancel, leaving me with just root 15. But of course, don't forget that negative sign out front. Okay, the next one we're going to look at is an expanding question. So this is the distributive property. So this is going to deal with multiplying radicals. And when we multiply radicals, we have to multiply the coefficient by the coefficient and the radical argument by the radical argument. Of course, the coefficient in front of this radical is 1. And so we'll carry out this multiplication. 2 times 1 is 2. Then root 2 times root 7 is going to be root 14. Carrying forward the other multiplications, we've done that one. We'll now do this one. We're going to multiply 2 times 3 to get 6, and root 2 times root 3 to get root 6. Now we should always check to make sure that it doesn't reduce, but of course, because root 2 and root 7 aren't divisible by squares, and 2 and 7 are prime, this isn't going to reduce at all. And so we're finished with this one. Moving on to a slightly more complicated expanding problem. This is one where we're going to have to use the distributive property over a pair of binomials because we have 2 terms in the first and 2 terms in the second. So we'll do our FOIL. So we'll do our first times our first. So that's going to be 3 root 3 times root 3. Now the square root of 3 times the square root of 3 is going to work out to be the square root of 3 squared. So then I'll have 3 root 3 times negative 2 root 2. So that's my outers. So I'll have negative 6 root 6. Then I'll do my inner terms. 4 root 2 times root 3. So that's going to be plus 4 root 6. And then lastly, I'll do 4 root 2 times negative 2 root 2. So that's going to be negative 8. And then root 2 times root 2 is just root 4. I could have written it as root 3 squared as well. And I did this way just so I could show that the square root and the square are going to cancel out. Because when you square root a square, it cancels. So when you square a square root, it cancels as well. So we'll have 3 times 3 is 9. We can combine our like radicals because they have the same radical arguments of root 6. We have negative 4 root 6s plus 4 root 6s. Sorry, I misspoke. Negative 6 root 6s plus 4 root 6s to get negative 2 root 6. And then this time I didn't do these root of 2 times the root of 2 is the root of 2 squared like I did with the 3. I expanded it to negative 8 root 4. And I did that so you could see that another way that this works. So the square root of 4 is 2, which would have happened from root 2 times root 2. So this will be minus 16. And we'll combine our constant terms. Sorry, our integer terms. And so we'll have negative 7 minus 2 root 6 as our final answer. Hope this helped.